the question was about producing a entry signal when the ADXVMA, all right, so you can see that this is the ADXVMA indicator I have on my chart here, right? So when the ADXVMA basically changes colors, and I want to, impress that you cannot read an indicator's color, right? So we get questions all the time, how do I build a signal when my indicator changes colors? Well, colors can't be read. So there has to be some other condition that has to be known, that can be identified, when the indicator changes colors. As far as the ADXVMA goes, I'll show you that the indicator actually has a hidden output that can be read that tells you when the indicator changed colors. So we'll go through that in just a moment here. So again, getting back to the question, so this is a two-part question. The first part is producing an entry signal when the ADXVMA goes from flat to a directional movement, so either long or short, right? And then the second part is exiting, building an exit signal when the ADXVMA goes flat again, right? So pretty common thought, right? A pretty common thought when you first come across this indicator, this ADXVMA. So, and this one is from Lizard Trader, right? So this ADXVMA on my chart is from Lizard Trader. So just so everybody's clear. So, right, you can see right there, it's the AMA ADXVMA. And you can find it inside the Lizard Indicators folder. So if you open up the folder, there's the indicator, right? And actually, Lizard Indicators or Lizard Trader, same company. They actually have two different versions of the ADXVMA now. So they have this standard one and then they have this plus one, right? So I'm just using the standard one on my chart here. All right, so that's the two-part question. Building an entry signal on the first bar, that the indicator, starts rising or falling, and then an exit signal when the indicator goes flat again. All right. So let's get BloodHound open, and we can start building. I'm going to switch over to the Logic tab here, and we need to create a new logic template, so hit the new button there. And now we can see the logic template has been created. And let's see here. There we go, just put a little comment in there. All right, so on the first bar there. And you know what, I don't ever mention this enough, but if you notice the green little triangle here, so if you click on that, that opens a little description area. So you can actually put a little description, of what this logic template does. So I can do something like that. So there you go, right? So you can write yourself little comments, as a reminder as to what exactly, this logic template is doing there. So, all right, so back to building the system here. So we're going to identify when the ADXVMA is either sloping up, right, or sloping down, right, when it's red. So, and to do that, we're going to use a threshold indicator here. Now, normally you might think that you would want to use the slope indicator, and that would be a correct, normally using the slope solver would be correct, but what you'll notice with the ADXVMA, there we go, perfect. Actually got a great example. So look here. Sometimes the ADXVMA, even though the coloring is for flat, right? But it actually has a slope on it. We can actually see, that the white area is sloping up. So, the way that this indicator was written, using a slope solver on it doesn't always work because the flat colored areas can sometimes have a slope to them, right? So using the slope solver, would be correct for other indicators, but for this specific indicator, we would get a long signal when the coloring is actually telling you that the indicator is flat, right? It's in a flat trend. So that's why we're not actually using the slope indicator with this particular indicator. The slope solver with this particular indicator. So, and that's why I'm using the threshold solver instead. So, all right. So let's give this a name here. All right. So for the input, we're gonna replace the SMA with the ADXVMA. So let's click that open. So we're gonna go into the Lizard Indicators folder, and there is our ADXVMA. And I'm just using all the default settings. So like an 8 period. Let's see. Yeah, that's all there is, just an 8 period. So now, as far as the plots, right, we can see that there is the ADXVMA plot, so that's the line that we see on the chart. But there's also this data series, and it's called trend, right? So this is what I was talking about earlier, saying that the indicator has a hidden output, all right? So this data series, you can't see it on the chart. You'll never see a data series on the chart, but it is an output, and it can contain data that looks like a plot. Sometimes it will, sometimes it won't. So the data series is a way for one indicator to communicate with another indicator without drawing stuff on the chart, right? So because you actually would not want to see this data, this information on the chart. So we want to access this trend information here. And so I already know, since I've worked with this indicator a lot, so I already know that what the data, or the values is, I should say the values that are contained in this trend is a -1. So when the indicator is red, this trend equals a -1 value, right? When the trend is flat, right, or when the indicator color is flat, this trend equals a 0 value, right? Even when it's sloping up, right? So where I circled it, right, the color is flat, but the trend is going to equal a 0 when it's colored flat. And then when it goes blue, the trend equals a +1 value, right? So this trend only equals 3 different values: +1, 0, or -1, right? And that tells you, is the ADXVMA, is it trending up, or is it flat, or is it trending down? So that's what this trend here does, right? And so for other indicators that provide, this data series, normally you will have to go to the developer, to the programmer, whoever wrote the indicator. You're going to have to ask them for documentation on what values, does this hidden data series contain, right? There's no way for shark indicators to know how, some other programmer, coded their indicator, So when you do find indicators, with this hidden data series, or it could be an int series, there's other data types here. Basically, you have to go back to the programmer and ask them if they have documentation on what these hidden outputs, what values do these hidden outputs contain, and under what conditions of the indicator. So, all right, so we're going to use that trend. And the last part here is I need to set my outputs here. So we're going to put a 1 for the greater than A, so for the long output, greater than A is going to equal 1. And then for the short output, we're going to use less than E. Like that. And there we go. Now we can see, right, BloodHound now matches the indicator, right? So whenever the indicator is blue, we get a long output. And when the indicator is red, we get a short output, right? And of course, when the ADXVMA is in a flat state, you know, then no output. Right. So now we actually, you know, we have an output that matches, you know, the trend of the ADXVMA. So now we need to just isolate. Let's see, where was that working? There we go. So now we need to just generate, right, a single signal on the first bar, right? So we don't want all of these entry signals, right? That is the incorrect way to build a trace system, right? Is generating signals on every single bar, right? The proper way, you know, if you go and look at, you know, every indicator ever built out there, you know, by various programmers, they only generate an entry signal on the first bar, right? They don't give you all of these other continuous entry signals, right? So we need to, we need to cut this down here. And there's two ways we can do this. The easy way is I could use a signal blocker, right? And the purpose of the signal blocker is to block all those signals, right? And with the signal blocker, I would need to increase the block signals for, right? So the block signals for that. So we want to block signals for probably at least 50 bars. And now we can see, right, those other signals that were in the middle have disappeared. And so if we take a look, that should have cleaned everything up here. So, oh, and yeah, so you notice we're missing a signal right there. Right here where my cursor's at, right? We're missing a signal there. So to clean that up, or to get that signal back, right? So there we go. Yeah, we're missing the signal right there. So to get that signal back, we need to adjust the resets, right? So let's see, we're not using the reset signal, so let's turn that off. Input opposite signal, yeah, we want to leave that on, but we also want input no signal, right? So the input no signal, what that does is when the ADXVMA goes flat, right? It goes flat. So let's look at our input signals, right? So we have a couple of long signals here, right? We have a couple of long signals, and then we have this area of no signals, right? There's no entry signals when the ADXVMA is flat. And so when there's no signals, we want to use that to reset the signal blocker so that then, you know, then we can get another entry signal again here, right? Let's connect that in. And so this input no signal, we're going to turn that on, and voila, there's our missing entry signal there. So, all right, and so now I think that should do it. And so what I'm looking for is when we have these really long runs, you know, I want to make sure that there's no secondary long signal during this really long run. And yeah, it doesn't look like there's any problems here. Yeah. So you know, when we do get these really long trend runs, Yeah, I'm not seeing any secondary signal. So what that means is that the signal blocker, it's, you know, blocking for 50 bars is plenty of bars to block for. So I don't need to increase this value anymore. All right. And so I'm not going to go into depth on the signal blocker. There is a dedicated video on how this node works, right? And again, the signal blocker is one of the function nodes here, right? So there is a video on the signal blocker, so that way, you know, you can learn, you know, what do all these resets do, you know, and what do all these other settings do here. So, but I will quickly state that you shouldn't go in here and just willy-nilly put a very high value in there, because the higher this number is, the more processing power is required to run the signal blocker, right? So basically, when you get a bunch of these nodes in here with high values, such as like 500 or 1,000, it can begin to slow down your system, right? So just be conscious of that. You want to use as low a value as reasonable, but of course, if you go too low, so let's say if I put in 25, right? If I put 25, then, you know, I get my first signal, but then I also will get this secondary signal, you know, before the trend comes to an end, right? And so obviously, you know, you don't want these secondary signals here. So this number needs to be high enough to eliminate those secondary signals, but not so high that it's going to impact the performance of your system. So, all right, so that is one simple way to kind of clean up, you know, your signals here, right? So again, if we take a look at, you know, if we look at the raw signals, right, we get this continuous run of continuous signals, right? And so to clean that up, that's basically that's what the signal blocker is there for, is to clean stuff like this up, right? A very simple way of cleaning up your signal. So the first signal gets through, you know, and cleans it up, and you get a discrete signal, and all the others, you know, are blocked. So, but then there's also another way that has limited capabilities, but we could also, let's see here, yeah, so we could use some Boolean logic here, and let's see, oh, wrong one. There we go. I want the XOR node, and so with the XOR node, right, we can see I get a signal on the first bar, but also I get this signal at the very end here. So when the signals come to an end, then I kind of get this last signal. So I get the first signal and the last signal there, right? So we need to get rid of that last signal, and the way I can do that is I just need another logic node here, an AND node. Connect that in, and that cleans it up, right? So using, you know, Boolean logic here, I can perform the same function as the signal blocker, but of course with this Boolean logic, you know, I don't have all these reset capabilities. You know, this is so using this Boolean logic only can clean up, you know, can clean up a specific type of entry signals here. You know, so basically, if you have, so if your system, so if you built a system, you know, that gives you these long runs of entry signals, this is these are the only types of entry signals it can clean up. So it does have a limited state, right? And so the next follow-up question is, well, why would I want to use this Boolean logic versus using the signal blocker, right? The signal blocker looks so much easier to build and easier to remember. And again, you just kind of have to look at your system's performance. So as I mentioned earlier, with the signal blocker, right, the higher this number gets, the higher the block signals for, the higher that number gets. Remember, it requires more processing power the higher that number gets. And also, if you start using a whole bunch of signal blockers, they will compound and, they kind of get added together, as far as the processing computing power that they require. So multiple signal blockers, with somewhat high numbers can also, they add up together as far as impacting your system, So you kind of have to look at your system as a whole to decide, can I just go the simple route using a signal blocker, or do I need to implement this Boolean logic to kind of simplify things? So this Boolean logic uses basically virtually almost no processing power. It's just it's very simple to calculate compared to signal blockers with high numbers. Now as far as this simple system goes, a signal blocker is fine. There's no need for this Boolean logic here, but I'm just kind of using this opportunity, to kind of introduce the secondary way to block signals. So either one works perfectly fine for this simple system here. All right, pretty straightforward there. So we get a signal on the first bar when the ADX starts sloping in a trend direction, right? Or gives us a trend directional movement there. So now we need to build the exit signals. We got part one done, the entry signals, and part two is the exit signals here, right? So we need to create a new logic template here, and there we go. And this will be our, all right, so this is our exit signals, right? So now from the drop down menu, right, this is why logic templates exist. So because you might want to build a couple of different entry signals, depending on market behavior, or maybe you're just kind of testing different ideas out, right? So you might have a couple of different logic templates, with adjustments, to the entry signals, or different logic templates, where you build different exit signals as well. Okay, so the exit signals here. So we want to know when the ADXVMA goes flat, we want to build an exit signal there. So, there's a couple of ways I can do this. I'm going to build another solver here. So I'm going to grab another threshold solver. Let's zoom in there a little bit. All right, So this new solver here is going to identify when the ADXVMA is flat. All right. So let's go into our input and let's select the ADXVMA. And again, we want to select the trend data series there. And of course, remember, if you're using different periods, don't forget to adjust the period setting for your indicator. Right. And now, as far as the output goes, there. So this time, so remember that, let's take a look here. So remember this trend output, remember I mentioned earlier that it equals 0 when the ADXVMA is in a flat state, right? This trend equals 0. So for the threshold solver, right, we can see B, right? Basically all my thresholds are left at 0. And so we want to know when that trend equals 0. So for my outputs, I'm using at B. So what is B? B equals 0. You know, C equals 0 and D also equals 0. But as far as the outputs go, you know, we only need to select one of the outputs that equals 0, right? We're not looking for a value greater than 0, right? We're looking for a value that equals 0. So that's why we're using at B, because we want to know when that trend output equals 0, not when it's greater than 0, you know, and definitely not when it's less than 0. So that's why we're using the at B. So at B means, you know, at 0. So there we go. And that's all we need. We don't need to clean this up. Exit signals in general typically don't need to be cleaned up. And in this case, they don't need to be cleaned up because the only time you need to clean your exit signals up is if there's an exit signal on bars where there's an entry signal, right? And so we know our entry signals, you know, are going to be after the indicator goes from, you know, flat to trending, right? The entry signal is going to be on this bar. And so we can see these exit signals don't interfere with the entry signals. So we don't need to clean these up. Yeah, and so I would suggest, you know, don't use a signal blocker, you know, unless you absolutely have to. Just leave it in its raw state, you know, because that uses less processing power. So there we go. There's our exit signals. And so, yeah, if we take a look, there we go. Every time the indicator goes white, right, we can see we get an exit signal. That is it. Let's close that. So on the top of your chart here, from the, you know, the BloodHound button, we can select the entry signals, and then we could also select the exit signals. All right. And I guess, you know, and then the last thing, just to kind of round this out to create a full picture here, you know, the last part would be, you know, loading this into Raven here, right? Loading this into the strategy. So let's open up the strategy window here. And we'll go into the Shark Indicators folder. And there is Raven. So with Raven, you know, you would load in, you know, the template file for today. And so there is today's workshop file. You load that in, and then you can see you have entry logic template, right? Entry logic is for your entry signals. So that would be our ADXVMA entry signals. And then, you know, this system actually has exit logics, right? So most of the time, you know, your exit logic is just going to be left blank because most people don't develop exit signals. But in this case, we do have exit signals. So we can then go and select the ADXVMA exit signal logic template. All right? And that is basically how you would set this up, you know, within Raven. All right. It looks like Gilles got his answer there. So good. All right. I don't see any follow-up questions. So I think we're done with this topic.